let's move on to simultaneous equations. And in simultaneous equations, we are trying to find the unknown values of x and y that are solutions to two different equations. On a graph, this means that we're finding the coordinates that appear on both graphs or the points of intersect of both functions. As a result, solving simultaneously for a linear equation will yield at most two solutions. On the below function, you would see that the solution for a simultaneous equation of two functions would be at these two intercept points. Okay, let's take a look at this example of solving simultaneous equations. I like to divide my equations into two, labeling them equation 1 and 2, and we're going to start by dealing with the simplest appearing equation in this instance. That is going to be equation 1. Y plus x is equal to 12. And I want to isolate one of my unknowns, which is y. I'll do so by making y equal to 12 minus x. And now I have a value of y in terms of x. I'm going to substitute that into my second equation, which is xy is equal to 14 minus 3x. To substitute this value of y in, you'll get an example of 12 minus x is equal to 14 minus 3x. And we're just going to solve for x in this equation. 12x minus x squared is equal to 14 minus 3x. And I'm going to move everything over to one side and make it equal to 0. So the final answer is going to be x squared minus 15x plus 14. Okay, we're going to factorize for this, and our final answer is going to be x minus 14, x minus 1. Therefore, x is going to be equal to 14, and x is going to be equal to 1. Now we know our x values. We are going to substitute both of these back into our first equation, which will give us our y value. So y was equal to 12 minus x. Therefore, y has to be equal to 12 minus 14, and y has to be equal to 12 minus 1. In solving this, we'll get an answer of y being equal to negative 2 and y being equal to 11. If we were to depict this graphically, we would get 2 points of 14, negative 2, and 1, 11. And that is how you solve a simultaneous equation using substitution. Okay, I would like you to pause and try solving this example, after which we'll come back to it and we'll see how you did. Wonderful. Now that you've attempted it, let's see how you did. Okay, in approaching this equation, I divide my simultaneous equations into two, and I deal first with my equation 1. I'm going to try and isolate my y, and so I will get 3y being equal to 2 minus x. I want to further isolate y, so it's all on its own on that one side of the equation. So y is going to be equal to 2 minus x over 3. Okay, we have got our y value in terms of x, so I'm going to plug this into our second formula. X squared plus 4xy minus 5 is equal to 0. In plugging that in, we're going to get values of x squared plus 4x, which is multiplied by 2 minus x over 3, minus 5 is equal to 0. Therefore, x squared is going to be x squared plus 4x multiplied by 2, 8x over 3, 4x multiplied by negative x, minus 4x squared over 3, minus 5 is equal to 0. Because this is an equation, I can multiply through this denominator, which will give us values of 3x squared plus 8x minus 4x squared minus 15 is equal to 0. I'm going to further simplify this equation by adding our two x squared values. Therefore, our final equation is going to be negative x squared plus 8x minus 15 is equal to 0. And we're going to factorize that out first by dividing through the negative. We're going to say that is x squared minus 8x plus 15 is equal to 0. Therefore, if we're looking at our factors of x are going to be 1 and 1. And if we're looking at our factors of 15 are going to be 5 and 3. To get a negative 8, we are going to say x minus 5, x minus 3 is equal to 0. Okay, therefore, we have our x values. X is equal to 5 and x is equal to 3. Let's solve for y by plugging in our x values into equation 1. Y is equal to 2 minus x over 3. Therefore, y is equal to 2 minus 5 over 3, and y is equal to 2 minus 3 over 3. In the first equation, our y value 2 minus 5 over 3, 2 minus 5 is going to be negative 3 over 3. That's going to give us an answer of negative 1. And then our second calculation, y is equal to 2 minus 3 over 3. 2 minus 3 is going to give us negative 1. Therefore, y is going to be equal to negative 1 over 3. These are our two x and y values, and you have solved your simultaneous equation. That is the end of our section on algebra, equations, and inequalities. I hope that you've learned something today, and I hope you enjoy the rest of your studies.